So let's start. So far, we've talked about what data mining is and what are the main techniques and topics that we cover in class. So last session, I didn't have time to cover the last few slides. So before we move on to the new topic on data preprocessing, I'm going to just quickly cover these few slides which are discussing major issues in data mining. So here you can see a few of like these issues such as efficiency, effectiveness, user interaction, privacy, fairness, interpretability, and I'm going to discuss each of these separately. So efficiency, as you know, in real world we said that data that we are using are huge, right? Millions of rows, attributes, and so our algorithm should be fast and also scalable, right? And so that's why the efficiency is a problem, because we need to use, for example, smart data structures. That's why we use, for example, parallel or distributed computing and so on. And it's sometimes, not always, but sometimes it's good to get good answer quickly rather than just getting a perfect answer in a really long time. And then about effectiveness or accuracy, how to develop models from data to make accurate predictions on future data. This is also an important aspect because we want to see if whether we can actually predict accurately on the new, for example, unlabeled data. And also we want our results to be interesting. And user interaction. So these are mainly like not mostly like theoretical, conceptual topics, but I'm just quickly covering them in case if you have any questions. And user interaction, so this is also a very important part because one side is the user that is using, for example, a system for which you are using, for example, data mining techniques, right? And it's important that they also found the knowledge that you infer from this helpful and meaningful. And the modern data mining systems are all interactive, and they also incorporate feedback into their system. And some techniques that can help are, for example, visualization of the data that, for example, as one helpful way to make it more interactive. And data mining with privacy, this is also very important because now we have like our data are used almost everywhere, like in social media platforms. All the application that you use, they need login, register, creating an account. And so this is a very important concept, especially nowadays with like more and more things getting just more and more digitized, and social networks and so on. So not only that, also, for example, let's say, think about your purchases everywhere, right? So this is also a very important concept that we need to keep users' data private, and data mining itself invade privacy, right? So that's why this is a challenge in data mining. How can we ensure privacy? Several ways. For instance, like in databases, if you want to store credit card information, do you store credit card numbers directly in the tables? No, they often use, for example, tokenization. Or for example, if you want to store data, let's say I collected, I think I told you that I've used Twitter data for my PhD, and then the data that the Twitter API provided me with included lots of users' information, but of course, anonymous user IDs, right? So I didn't have access to the actual, for example, IDs or names. And this is also important if you're creating a data set, like for example in web scraping and so on. You always need to, for example, in data, if you're creating a data set, make sure that you keep user IDs anonymous. And what else? Multi-party computation and so on. Fairness and bias in AI. A model is considered fair if errors are distributed similarly across different groups of data. So it's like you make mistakes, equally across different places or different groups. So when models are unfair, they are also often, like, the unfairness of a model is mostly because of the bias it has. And there are several reasons that it may get biased, mostly also relevant to the data. We talk about that today in data preprocessing, that, for example, if you don't handle noisy data well, then your model can also learn noises instead of patterns and result in biased model. So interpretability, another very important concept, especially in e-commerce, healthcare, and so on. You're suggesting a product to a user to buy, right? So it is more convincing if you provide also reason why he should, for example, buy that, or why, for example, I should watch this movie next, because it's, for example, because you liked, for example, these movies, you know. Because, for example, you liked, I don't know, Inception, you may like, for example, the other movie that is similar to that movie. This is also more convincing from users' point of view to understand why to make certain actions. What is the answer for this? Which of the following task is a data mining task? Sorting a customer database according to a customer name. Is it a data mining task? Assuming you have a customer database and you want to sort it according to names. No, this is not, you're not finding any patterns, right? You're not predicting anything, you're just sorting like a column of names according to a name. Computing total amount of sale in the past month. No, this is also not a data mining task. Predicting wheat growth using a crop simulation model. Is it data mining task or not? How many of you say yes? How many say? Okay, so those of you who said yes, why?
We are predicting the growth, prediction for the future based on the previous data, based on the model, crop prediction model.
Yeah. Grouping students in a student database according to the pathways the student traversed through their university studies. A pathway consists of a sequence of events such as a transfer from full-time to part-time, winning of award or scholarship, failure of a course, and so on. Is this an example of data mining task or not? How many of you say yes? Great, why? Yes, yes.
It's classified based on the
Yeah, so grouping students based on their study plan, a study path, over time, involving sequences, patterns, right? Discovering a structure from the data. So this is data mining. More specifically, this is sequential pattern mining, which we cover later. And extracting frequencies of a sound wave. No, that's just signal processing, right? Now, predicting wheat growth using a simulation model. This is actually not a data mining task. This is just a physics-based model. So this is a bit tricky. I understand why some of you said yes. And okay, get ready to join. Why it doesn't have any sound? Oh, it's coming from my computer, that's why. Has everyone joined? Three more people. What are you doing? One left. So 4 of you are still not joining. Who are those 4 students here not joining my game? Anyone has any problem joining Kahoot? Okay, so I'm going to start. Someone joined in the last minute. Okay, which of the following is a data mining query rather than a data So in order to get points, you don't only have there are two factors. First, choosing the correct answer. Second, how fast you choose, right? So if you choose fast, then you get more points. And then for the 3 first people who come on the podium, so the first person here, and second, and third, so you get and more towards female here, and 0.5% bonus towards your final mark. Okay, so let's see. JY. Who is JY? Yes. Okay, next question. Model takes a sentence and output 1 label for every word. What type of predictive task is this? Okay. 5 people chose the correct answer. That's good. 20 people said classification. So model take a sentence, output 1 label for every word, right? For every word. That's why it's a structured prediction. So Aijun. Yes? Is it Aijun? Supermarket analyzing last year data find that high spending customers tend to be middle-aged and living in areas. Yes. I love these questions. 4 people chose the correct answer. So those 4 people who chose the correct answer, explain. Why is this summarization? Oh, don't tell me you chose randomly. No. Who picked summarization? Who chose this? Okay, so why?
It's because it's actually getting a conclusion from the data that summarizes the part.
Okay. Those selected classification. Why did you think it's classification? We are analyzing last year data, finding high spending customers. So how is this a classification? What is classification? A supervised learning method, right? In which you have labeled data, you train your model on the labeled data to predict, right, the class labels or unlabeled data. And you can, for example, predict if an image is a cat, dog, etc. You can predict, for example, if diagnosis is flu, cold, and so on. So that's classification. And there was one more student selected summarization. What was the reason for choosing this? Yep. You chose summarization? Yes. Why is this summarization?
Definitely not classification or regression. And time series is like doesn't sound that right.
Okay, so that's also a way to choose the correct answer. So exclude the others. Anyone remind me what is summarization? Ring a bell? No? Four people selected this option. What is that? We focused on one category, right? Do you remember? Concept. Yeah?
Describing one category.
Yeah. So that's why it's summarization. And definitely not regression. We are not predicting any like numeric value, not time series prediction. And Fear is on fire. Okay. Am I saying, okay, now this is good. So, which statement best distinguishes clustering from classification? So, okay, that's good. Clustering discover groups without knowing labels. So clustering is unsupervised, right? We don't have any labeled data. We are just grouping data based on how similar they are with each other. Okay. Why would applying a machine learning classifier directly to raw data usually fail in practice? That is without any data preprocessing. Okay, nice. Raw data is often noisy, missing, and inconsistent. So as I mentioned, for example, if you don't deal with missing values or you don't deal with like noisy data, then you get your model may, for example, learn the noise instead of learning a pattern, right? Causing the model to become biased, for example. Or if your data is inconsistent or incorrect, then your model is also learning incorrectly. And so raw data is often noisy. This is the correct answer. Which of the following is not data mining? Finding customer segments, clustering, detecting fraud patterns. We can use different models. Discovering which products are bought together. Association rules, for example, association rule mining. Computing total sale last month. This is not a data mining task. It's a database task. A company predicts house prices using size, location, age, and distance to subway. Best method. Multiple linear regression, yes. So those two people selected classification. Why? Why is it a classification? We are predicting house prices using size, location, age, and distance. So we are using multiple columns, right, to predict a price. Price is not a categorical value, right? It's a numeric continuous value. So it's a regression. So no classification. And now which type of regression? It's not simple linear regression, because simple linear regression, we just have one independent variable, right? So you learn based on just one one attribute or one feature. But here we have size, location, age, and so on. Which data type best fits market basket analysis? Everyone should answer this correctly. Should I assign penalty for anyone answering this question incorrectly? No? Okay. How is this a graph data? Okay, transactional data. Which task cannot be solved without label data? Okay, so market basket analysis, what type of analysis is this? Do we need like label data for that? For market basket analysis, for example, we use association rules. You may use also frequent sequence pattern mining. So these are not, they don't need any labels. Regression, we need label data, right? Because we want our model to learn from the training data. For example, you have like the previous example, right? You have, for example, information about houses and you want to predict the price. Clustering customers. Clustering is unsupervised. No, we have unlabeled data, right? In unsupervised learning, we don't have labeled data, and we don't actually know what we want to predict, right? We are just looking for patterns, grouping, for example, the data points. Last question. Which task is predictive but not classification? Okay, nice. So the question asks which one is predictive but not classification. Detecting spam emails. This is a classic classification example, right? Assigning risk levels like low, medium, high, again classification. Identifying fake news. This is also classification. You are predicting whether a piece of news is true or false, right? Labels are true or false. Then this is also classification. Estimating delivery time in minutes. So this is not a discrete value, right? Predicting discrete value. So this is not classification. So let's see who are on the podium. Aijun on the first place, Kabir on second place, and our most private players are in the first place. Okay? So you guys have to, I mean, you don't have to, but you can let me know who you are at the end of the class if you want to. Okay, data preprocessing. So, today we are going to start a new topic on data preprocessing, which is a very important step. Almost no one talks about it, but you will spend most of your time on this. And so why we need data preprocessing? Why do we need to do any processing on the data before, for example, we feed it to our model? Because real data are messy, right? They are huge, messy, including many nulls, duplicates, inconsistent values, inaccurate values, and so on. So we need to do data preprocessing. So we will talk about data cleaning, data integration, data transformation, and data reduction today. Hopefully, if we have time. If not, we continue next session. And so what is that? It's a processing of transforming or converting your raw data into a format that is understandable and suitable for analysis. So everything we do to make your raw data ready for analysis, that is data preprocessing. And the reason for that, as I said, raw data is messy, noisy, and not very helpful. And processing is just convert that mess into something that can be ready for analysis. And we do this to improve data quality and in terms of like different factors like accuracy, completeness, consistency, and so on. So accuracy is how close this data is the true real world value. For example, if a person is if person age is 25, but your data, for example, mention, 52, right? Then this is not accurate. Completeness means how much of the required data is actually present, if it is complete or not. For example, you may have missing values in certain columns or rows. And consistency, it means the same data should be represented the same way across different places. For example, let's say if in one table or one data source you have, for example, weights in kilogram, you don't want to see pound somewhere else, right? And things like that. You want to stay consistent. Or for example, if you are using a student ID somewhere and then a student number somewhere else, both of them referring to the same thing, which is the unique identifier for the students, but the names are different, making inconsistencies. And timeliness means how up-to-date the data is. So for example, old prices, right? Outdated, for example, prices, and so on. Believability, how trustworthy and reliable the data is. For example, if you are collecting data through web scraping and crawling, is that as reliable of the data set, for example, you collected from a hospital? Of course, the data from the hospital is more reliable, right? Rather than like the noisy data that you get on the web. Interpretability, how easy it is for users, humans to understand. And for that, we can also use, for example, clear column names and so on. So that was just like overview. Now, why we do pre-processing? First, data come from different sources, and this also, as I said, may cause inconsistencies and so on. And also because we may need, like in practice, for most analysis, you may not have all the data in one data source. For example, you may need the traffic data and at the same time also weather predictions and so on to make a better prediction, because that also affects the traffic, the weather, for example, information. Second reason is that data is dirty, and so some values are missing, some values are duplicated, some of them are inconsistent, and so on. Third, data may not be in the right format, so you may use like incorrect format, and so for that we are also use data transformation that I'm going to explain today. We often normalize values or discretize numbers and so on. And finally, because we have too much data, sometimes, for example, you have billions of rows, but maybe like not always more data is not better, right? So sometimes even a subset of that data, you do sampling, for example. If you do sampling appropriately, that is representative enough. And then, for example, instead of using billions of rows in your computation, you can use only, for example, a subset like hundreds of rows. And here are data pre-processing main steps that we are going to talk about. Data cleaning, dealing with missing values, dealing with duplicates, dealing with inconsistencies. This is all about data cleaning. Data integration, do you think what it refers to? Data comes from different sources, right? So we may need to integrate data from multiple sources. Data transformation, so we may need to change data into a format that we want. Data reduction, as I said, data is huge, right? Real world data is huge, and you may want to just use sampling or other techniques to just use a subset of that data, but we have to make sure that is a good representative of our data. Now, data cleaning means just fixing bad, messy data. Process of removing incorrect, incomplete, inaccurate data, also replacing the missing values. So, bad data include what? Missing values, inconsistent values, incorrect values, noisy data, and we have to learn how to deal with each of them, which we do today. How do we do that? For example, if you have missing values, there are several ways. You may remove that row or column, depending, for example, if you have a feature with lots of missing values, then that is not going to be helpful in your model, right? So you may want to just remove that. Or if your class label have lots of null values. And another way, sometimes you want to keep that feature and not completely remove that. You can fill the null values with, for example, something more meaningful, like maybe, for example, if it is like in weather data, considering the weather data, you may want to, for example, fill the missing values with mean or median of, for example, for example, past few days, right? And more on that later. I'm going to explain more on that. Data integration, as I mentioned, combining data from multiple sources into one clean, usable data set. Some problems that we have to consider here. The main question is that how do we know that records from different databases refer to the same, for example, real person, right? So that's the entity identification problem. How can equivalent real-world entities from multiple data sources be matched up? As I said, you may have a student ID from one database, a student number in another. They both refer to the same attribute of the same entity, but with different names. And using metadata often help, for example, knowing the keys to access, for example, data, pay attention to the structure of the data, and so on. And the second issue is value conflict. So, for example, again, as I mentioned, one system or one data source may store weight or weight, for example, in certain measures, in, for example, kilogram, the other in, for example, another measure, or, for example, height in centimeter or in inches, and so on. They are still the same thing, right? But they are represented in different ways, causing inconsistencies. Or, for example, you may have date shown in different ways, right? You can have different date format. We just want to make sure that we are using consistent format. Data transformation, transforming data into appropriate form for mining. This is very helpful. Attribute or feature construction in data analytics, we often do this because most of the time we come up with, in our analysis, we come up with something that is not explicitly provided in our tables or in our data, but it can be calculated. For example, computing average sale amount using total sale amount divided by units sold, because average sale is better representative of the trend and patterns, right? Comparing to, for example, let's say you have a column total sale and also another for the units sold, and then you create a new feature, average customer average sale. Can anyone tell me how is that going to be more helpful for analysis? Why is that feature more helpful? Think about what type of analysis, for example, each information can help you with. Like, for example, if you have total sale, in what, for example, analysis you can use that? Or, for example, what queries can use units sold versus which queries or what type of analysis can average sale amount be helpful with? Any idea? Yep.
For the total sale, we can see if we can keep selling this product or not. Is it like popular or not?
Mm-hmm.
For units sold, we can compare our price with competitors. Like, what's their price? For example, we sold for like 30 units. They sold for like 20 units.
Mm-hmm.
Like, is our price competitive?
So now let's say you have two customers. They are both spending, I don't know, $200. So the total sale for each of them is $200. And then one of them bought two items, each $100. Another customer bought, so one of them is buying two items for $100. So the total sale was $200. The other one is like has bought 20 items, each $10. Right? Now, having like creating new features, like for example, average sale amount, customer average sale amount, and these kind of features. So there is a difference between do you agree that there is a difference between a customer who bought, for example, two items, who spent $200, they both spent the same amount, one of them bought two items, the other one 20 items, right? So the type of, for example, in recommender systems, the type of recommendation you may provide for these two users are completely different. You may want to recommend more like higher price products to this one versus other, for example, cheaper ones to the other one. So these type of, for example, information are more useful, or any, like this was just one example. You may have, you may also create features only because you need one column more. For example, you may have date of birth, but you are, in your analysis, you consistently using, for example, age, right? So it's helpful to just using the today date, computing age, instead of like converting date of birth to age every time you want to use that for your analysis. And then we do also normalization. So some features are huge. Like for example, let's say you have salaries, right? Let's say you have a model that want to learn based on different features, and those different features are age, salary, income, and so on, right? Now, what is the range, for example, for age, person age? The range for person age can be 0 to, I don't know, 100. And the range for salary could be what? 0 to 200K, 300K, 500K, or even more, really large number, right? So the range is very different. Now, the problem is that most machine learning algorithm, or most algorithm in general that we use also in data mining, they then treat like like salary that has higher ranges as more important, while it doesn't necessarily mean that it is more important, right? So we need to normalize or rescale some values, put them, for example, between 0, 1. So giving them like the same importance for the model. And data reduction, here we talk about why sometimes a smaller data set or data may be more helpful than using all your huge data. So many data sets are just too big to analyze. You may have like computational resource problems or timing limits and so on. If you have too many rows, your model will be slow. If you have too many features, then again your model becomes unstable. So more data is not always better, and that's why we do data reduction. And also, if you're adding too much detail, let's say you have too many features in your model, another problem is that you may also it may also cause overfitting. So it fit the noise instead of the actual pattern. And so sometimes it's a trade-off, right? You want to just trade off the a little bit of accuracy for faster and more reliable learning. Now, we have different data reduction operations. So this table is just showing the standard machine learning data format that you see. So each row is showing one example, and each column is a feature. And then you also have the last column, which is your target variable or your class label. Now, there are three ways to reduce the data. Feature reduction. What is feature? The columns, right? So feature reduction means just selecting subset of like these features in your analysis. So you remove unimportant like redundant columns. For instance, when I collected the Twitter data, there were like, and I built my data frames, there were many like columns and features, but not all of them were relevant for my analysis, right? For example, if I'm going to calculate, I don't know, tweets speed, right? What information do I need? Do I need all like user information and so on? No, I don't need that. So depending on the analysis, you may need different features, and you can exclude the others, and that makes also your analysis much faster. So feature reduction is one, reducing the number of columns, just keeping the important features or the relevant one. Case reduction, case means row, just reducing the number of rows. So for example, sampling 10,000 customers instead of 1 million customers, right? Just choosing the ones that are representative of your whole data. And finally, we have value reduction, which is reducing the number of distinct values in a column. So, for example, let's say you have a column age. Age can be from 0 to 100, right? So there are 100 distinct values of age. So instead of using 100 distinct values of age, using age as a range, right? For example, 0 to 20, 20 to 40, 40 to 60, and so on. So that will also be helpful in data reduction. So back to data cleaning. What was data cleaning? Don't sleep. Yep.
It's like to make like methods to make sure like any outliers or any inaccurate data is like taken away, so it's easy to like utilize whatever you're doing.
Dealing with missing values, dealing with noisy data, right? Dealing with outliers and so on. So handling missing values, identifying outliers. So these are the main data cleaning parts that we do. If you train your model in a messy data, you will get a messy model. So that's for sure. And so for missing values, you may hear like none, null, and so on, depending on the context. For example, if you are using pandas, you will see usually like these missing values represented as none. If you are using SQL, you see them as null, and so on. You may, if you are, for example, working on a spreadsheets, you may see them as just blank. And so here you can see Titanic, famous data set. So this is a typical, if you have never used this data set, this is a publicly available data set, very helpful for start learning like data analytics and also applying some machine learning on that. So here, what are passenger ID, survive, P class, name, sex, age, etc. These are all your features or attributes, right? And what is your class label here? What is your target variable? Anyone has worked with Titanic dataset before or heard about Titanic dataset? So Titanic dataset contain information about passengers that were on the Titanic ship, and like demographic information about them, their name, sex, age, etc. For example, which cabin they were in, which part of the ship, and whether they survived or not, right? Now, what is the class label or your target variable? Cabin? Survived, right? We want to see whether a certain passenger survived or not. So that was your class variable. And so back to what I just mentioned, we were talking about missing values. So missing values can be represented as NaN, right? Here, because we have used, so this table that you see here is when you, for example, you may get your data in CSV format, right? And then you can import it if you are using, for example, I don't know, Jupyter Notebook or any like tools that you're using. You can use some very helpful libraries like pandas in Python. So using pandas, that you will see that if you import your data, you will see that you have NaN, which is just for representing the missing values, right? So these are your missing values. And which feature have missing values here? We have age with some missing values. We have cabin with missing values, right? And you see that cabin is missing for many people, right? So what do you want to do here? How do you deal with such data set? Yeah.
I mean, it doesn't seem so important to just take out the column or just replace it with everybody.
Removing, so recall, we said, how do we handle missing values? Different ways. You can remove, for example, the column completely, or removing the rows containing NaN, or refill them.
I can see they survive their disease, so I can put some value.
Yeah, so you, depending on the situation, the analysis, you may decide, for example, to keep that column or row or just completely remove it. If you realize that keeping it doesn't help in your analysis, especially when, for example, the class label is missing, you may want to remove it. But if you, for example, see that no, you want to keep, for example, that column because it's still containing information for example, many users, but you still need to deal with these missing values, you can then replace those missing values with some numbers, and those numbers could be anything again that is more meaningful in that context. For example, average, right? Mean, median, mode, and so on. And so before doing any data mining, you have to decide what you want to do with missing values, noisy values, and so on. So handling missing values, filling missing values manually, which is not feasible for large data set, right? So one way, if your data set is small, one way is to just fill in the missing values yourself, but that is not practical like in real world, right? In real world data. Now, what do? You can remove the tuple containing missing values. What is the tuple? Rows or records, right? So you can remove the rows containing, for example, missing values, which is usually done when your class label is missing, because then that doesn't make sense to keep that row, right? You don't have the class label. And not effective when missing value is attribute spread in many different tuples. Another way is just fill it with a global constant, such as, for example, you can fill all values with 0 or unknown or anything. But it should make sense and it doesn't interfere with your analysis. And so here's an example. So in the previous slide, I mentioned different ways for handling missing values, like filling them manually, which I said if the data set is small, it's okay, but for large data set, which is most of the cases, it's not feasible. Then removing the tuple containing missing values. This is also may not be the best option, especially if you want to keep your data. It's only okay when the missing values is in your class label. And if, for example, you don't know, in the context of Titanic example, if you don't know whether a person survived or not, right? It's meaningless to keep that in your training data. What do you want to learn from that? You don't know, because which type of data in this, for example, table are helpful? The ones that we have the class label for, right? Because then the model can learn based on these features whether a passenger survived or not. But if the survived, for example, value is missing, then these information are not helpful because we don't know whether which attribute contributed to what. We don't have any information. So these are the basic ones. But what are the better ways or smarter ways to handle with missing values? Here I'm going to explain them. Replacing with central tendency measures. This is what we often do. For example, replacing them with central tendency measures or mean, median. So if the attribute is numeric, you can just replace it with mean and median, for example, like the weather data that I mentioned. And depending on the distribution of your data, always when you're doing data analysis, you have missing values, you want to fill your missing values, please check the distribution of your data, right? Because if your data is skewed, then does it make sense to use mean or median? Okay, wake up. What is mean? What is the difference between mean and median? Yep. Yep. So mean is the average, right? For example, when you say the average of the grades in data mining class was 80%, right? Let's say we have 40 students, the average is 80%. Can I say most students got 80%? No, we may had some outliers depending on the distribution. So if it was a normal distribution, then this is a good representative because mean and median are almost the same. And it's because median is the frequency, like the most frequent ones. For example, if I say the median of the class is 70%, but the average was 80%. This shows that I had some outliers, like some students with very high numbers, or maybe my average is low, right? But median is higher because I had some students with very low numbers, which caused the average lower down. And so if your data distribution is skewed, it's better to replace it with median rather than mean. And let's say if most incomes are around 40K to, for example, 60K here, but you have some few huge numbers, do you select mean or median? Median. You have some exaggerated numbers, right, which affect your mean. And local estimation, so mean if normal distribution, median if skewed, and another method is local estimation. This is even better and smarter. Why? Because you consider this estimation for a specific class. For instance, here, what are the class labels here? Which column is your class label? Am I getting too boring? Yes, I feel that. I feel that in your face. Okay, so, but we have to continue. Sorry. Sorry?
Can you explain the second point there? Median, skewed distribution?
Yeah, so I said if, for example, your distribution is not normal, that is, it's not like this. This is a normal distribution where mean and median are almost at the same point. But sometimes you have skewed distribution, right? I'm not really good in drawing, but something like that, right? So back to the example of the class, or even here. let's say you have some very high income in the company, like the CEO of the company is getting like $1 million, but most employees income is in the range of, let's say, 100K to 150K, right? But then you have like a few employees with like millions of dollars of income. What would be the average? So the average income may be, for example, 500K, but not because most employees get about 500K, because there are a few employees getting so high salaries that just skew the distribution towards higher number. And then you may have median income, or maybe median income, right? Which is 150K, I'll just drop here, 150K, right? And that could have been really funny if I was dropping here. So if I was falling here, 150K is your median, which means most employees' income is this number. Average is just average, right? And so local estimation is another method. This is even a better method. Why? Because you look at your class label. Instead of using one global mean, you use, for example, mean or median within the same class. What is the class label here? Credit, right? For example, you have customer information here, like age, gender, income, and based on like this information, you want to estimate, for example, whether they were like good credit or not. Or you have, you can even like, for example, if the missing values here, the missing values is for income, right? How do you handle this? Cheat. How do you handle this? Different ways. One way, as we mentioned, is to replace this with mean or median. Now, if the distribution was normal, you can just replace it with the mean income. Most of the time, with the median is more reliable, right? Because even if it's just normal distribution, then mean and median are almost the same, right? Now, let's say you replace it with median. That was one way. But a smarter way is to get this income, like, for example, replace it within that class. For example, if this person is with the class of bad credit, right? Credit is your class label, and this person had bad credit. You can only find the median of all employees with bad credit history, right? With bad credit, and then applying the median of that group, that specific group. This is more representative, right? For example, the median of income for people with bad credit might be much less than people with good credit. And then these two median may also be different. Now, you can also replace it with the most probable value. This is a model-based approach and is more accurate because your model learns and you can let the model just predict the missing values. For example, if someone is 35 years old, as you see here, gender is male and has bad credit, then you let the model, instead of you fill the missing value with median or anything, you just let the model to predict what income is most likely. How the model predict depends. It could be based on, for example, different models. And noisy data. What is noise? What is noisy data? Just want you to. I just want to wake you up. And real world data is rarely clean, as we mentioned, and noise is random error or variance in a measured variable. And so, for example, let's say you have temperatures like 23, 23, 22, 20, 21, 24, 80, 22, 23, 23. What is noise here? That 80 is a noise, right? Because it doesn't make sense. The temperature is like around 20, 22, and then you just get 80 degrees. So that is example of noise. And where does it come from? Different places. It could be faulty instrument. For example, it may be related to your sensor problem and data entry problems. So for example, could be typos or missing values or these kind of things because of data entry problems. And data transmission problems happen when you're just transmitting the data or storing them. And how can we handle noisy data? So far, we learned what is data cleaning, how we clean the data. And I just realized I won't have enough time to cover today's lecture completely, but don't worry, I'm going to continue that next lecture. I'm going to finish with the handling of noisy data. So how do we handle noisy data? Several ways: binning, clustering, regression. So what does binning mean? I'm going to explain something, and most probably you won't understand what I'm talking about now because I need to give you examples to better understand binning, but I try my best. So we group the nearby values into bins and replacing them with a number that is more representative of them. And for example, if you have that temperatures that I told you, 22, 23, 25, and then 80, right? And that 80 is a noise. You can just remove that and replace it with a most probable one, for example. In clustering and in binning, the most important thing is that you first sort the data, you partition data into bins, and then you can smooth by bin means, smooth by bin median, smooth by bin boundaries, and so on. I'm just going to quickly show you an example, but I'm going to come back again. For example, here is an example of one of the method of binning. So we have different techniques for binning. So here you have this data which is sorted. You have 12 values, and then each bin in equal width binning, each bin should have equal width, meaning that, for example, and you have this, for example, formula to calculate the width when you find the maximum, which is 34, right? Minus the minimum value, which is 5, divided by the total number of intervals that you want. For example, let's say 3, if you want to have 3, and then 3 intervals of equal size, then it gives you a number 34 minus 5, 29, divided by 3, almost 9, right? So it means your bins width are about 9. So it starts like 5, right? Plus 9, which is 14. So all numbers from 5 to 14 comes into the first bin. So 5, 8, 9. This is your first bin. And then again 9, for example, 14 plus again 9, which comes to 24. That's why you have these numbers up to 24 here, and so on. I'm going to explain this method in detail later. I just want you to have an idea what binning is. And smoothing by bin means, it just means that you are replacing all values in each bin using the mean of that bin. For example, what is the mean in bin 1? 7. So you replace all values with 7. What is the mean in bin 2? 20. So you replace all values by 20, and so on. Or smoothing them by bin boundaries, which I explain later. So back to the binning, and so that you better understand what binning means. So you first sort the data, partition into several bins, bin 1, 2, 3, 4, based on different methods. Then one can smooth them by means, by median, by boundaries, and so on. Now, what is clustering? We group similar data points together. We had examples of clustering a lot. Values that don't fit into any group are called what? Let's say you have this. This is one group, this is one group, and then you have some data points here. So what are these? Outlier. Outliers are just these data points that they don't follow any like normal behavior of other data points, that they fit into a specific group, and they don't just follow that behavior, and they are called noise or outlier. And another method is regression. Instead of trusting every data point, we just fit smooth curve or line, right, in your data to you're just finding a function that fits into your data. Another method is moving average. So don't worry about this. So next session, I'm going to explain each of these methods more in detail. So binning, clustering, moving average, and so on. Just to give you an idea, moving average, here we replace each value by the average of its neighbors. And so for example, you have a stock price which is fluctuating daily, right? But if you get an average of the 7 day, it gives you a better, it is a better representation, right? And another method is combined computer and human inspection. So so you can have algorithms to flag the suspicious trends, but then that is the human that is deciding what to do with that. And why is this important? And then you can leave. Because, okay, the algorithms can, for example, detect outliers, noise, and all like maybe abnormal behaviors, but you may not necessarily want to remove those behaviors always, because sometimes that may be representative of not a noise, but for example, a successful, let's say, marketing campaign, right? You wanna go further into detail of why that happened. So sometimes those like irregular patterns are also helpful. And have a good day.